Here we go. Good morning to the monsoon season. Have you heard this song before? Talk about emotion. I better stop right there because I'll get kicked off of YouTube again. Alrighty, let me get rid of this. And were we on this problem?
Yeah.
Have we done this problem?
Yeah.
And did I show you this?
Yep.
Okay, I want to talk about this. On the AP exam, you'll have a problem like this in which you will not be able to figure out the antiderivative. And it will say, it will be the calculator portion, and they believe that you know how to use your calculator to do the calculator portion and are going to do the calculator when you do the calculator portion. And so they want, in this problem, they would want to see this as your work. They will tell you this. They'll tell you this function. They'll tell you this function. And so somewhere along the line, you'll have found A and B. So you could say this. A equals a negative 1.437 and B equals 1.580. You have to be correct to 3 decimal points. Then, you know how I showed you on your TI and your Casios how to put those values into A and B? Okay? You can always use them then if you choose to. To show my work, this will be perfectly acceptable. You will get all 3 points on part A. That's it. And then they're going to have a part B and they're going to have a part C. That will have to do with this function, and you can simply put those f of x and g of x and a and b in there because you've already told them what a and b are, and they've already told you what f of x and g of x are, so you don't have to rewrite them all the time, which is good because some of them are like really long, and if you have to write it every single time, if you're like me, you're screaming. Okay? And they're already in your calculator, so you just have to change your integral. Does that make sense? Okay? And they assume that you did this on your calculator, but this tells them, this form, you know how to figure out the area between 2 curves. Because that's all there is to it. That this was the top curve, this is the bottom curve. Now, if I reversed them, and wrote, I guess it's q of x. And if I had written q of x minus f of x, that's wrong. It would be negative. Would everybody understand why? Because this y value is less than this y value, and when you subtract a bigger from a lesser, you get a negative value. So your answer is always positive. When you do these problems, your answer is always positive if you take top minus bottom. You'll hear me say that all the time. Top minus bottom. If you have not noticed, Josh is taller than me. His height minus my height is a positive number. You're 70 what inches tall? You're 6 what? You're 6'7"? Wow. So you are 72 plus 7, you're 79 inches tall. I'm 65 inches tall. Your y minus my y is 14. Does that make sense? All right, so let's take a look at this one. This is a favorite problem of theirs to give. And if you notice, there's three of these. There's Rx is here, Tx is here, and a negative x plus 2 is here. So here's this, and here's this. Rectangle, rectangle, skinny rectangles. You know you can buy skinny popcorn? You can buy skinny jeans. They're taken over. I'm going to start a new brand. Obese popcorn, obese jeans. You're going to make tons of money. Because obesity, not skinniness, is an epidemic. Obesity. So there's got to be a lot of people that would buy Kruger's obese jeans. I can see it now. I'll have a little kiosk in the mall. You'll stop by and say, yeah, he used to be my calc teacher. People say, no way, he's a millionaire.
That kiosk be by your hair clip.
Yeah, I've told you that story too. Okay. Constantly thinking. All right, are these the same? Are they computed the same way? So you're nodding no. Why? Yeah, this function here is different than this function over there, correct? So I have to integrate them separately, don't I? I have to, right here, I'm going to integrate from 0 to whatever that point is, correct? And then integrate from that point, and I'm going to put plus, that point to this point. Well, I better figure this out. Let's see if I can do it without a calculator. Let square root of x plus 1 equal a negative x plus 2. And I get the square root of x equals a negative x plus 1. Does that look correct? I'm going to square both sides, get x. And over here I'm going to have x squared minus 2x plus 1, correct? Yes, ma'am?
Why are you making them equal to each
So I could figure out their point of intersection without a calculator. I'm seeing if it's possible. And then I get 0 equals x squared minus 3x plus 1. That's not possible, is it? Right? I can't factor that? Does that look correct, or did I make a mistake somewhere? So I need to figure out the intersection point. I suppose we better go to our machine to figure that out. So I'm going to put those three in there. On y equals clear mode, because I'm in polar coordinates. Y equals clear shift square root of x plus 1 negative square root of x plus 1, and then negative x squared, oh no, negative x plus 2. Does that look correct? Figure out their intersection, second calc. Casio people, you're already done. Am I right? Choose. I don't even know how to get to that. Choose. Do I get 0.38196601?
Yep.
Okay. So I'm going to integrate to what'd I say?
382.
0.382. And I'm going to have what minus what? What am I going to have? R of x minus what?
U of x?
Well, look down here. Is this u?
No.
It's what?
T of x.
T of x. And then I'm going to go from 0.382 to, did you figure out the next intersection point here? No. 2.618. And what is that going to be? U of x minus T of x dx. So I got to come up with two integrals. Ickety ick ick ick. So I'm going to have a bunch of different y's, aren't I? Did anybody figure that out? Anybody? Tegan, you did? What'd you get? Oh, I thought you had it. I'm sorry. I got time to put my hearing aid in.
Mr. Tudor,
Yes.
I'm so confused why it's R of x minus T of x.
Look at here. Where does this segment start?
Can you scoot it over?
Where does this segment start?
On R of x,
Where does it end?
T of x. So, but aren't you finding the intersection of that point up top?
I'm integrating from here all these rectangles till I get to here.
So, but isn't the intersection up top R of x on U of x?
Yeah, but the segment goes from R of x to T of x. I just need to know I'm in. Here's my A, here's my B. Here, this is B right here, this is A right here.
Oh.
I'm figuring out the area of this colored section.
Okay.
And so does everybody understand? That's this integral right here. This first integral, let me back it out. Maybe I did a lousy job explaining. This integral right here is the area of this curve. It's that area. This is where that rectangle begins and ends. Here, I would actually have to get a different color and say, all right, these rectangles are this color. And it starts here and goes to here, that interval. And that's this baby here. Does everybody understand that? Did we come up with an answer?
I got 1.863.
Tegan is nodding affirmatively. How about if I talk correctly? 1.863. Okay? Now, Nikita, You're way back there. You see this rectangle right here? How thick is it?
Delta X.
Dx, delta x. Correct? That's how thick it is. Every one of them's that way. This is a lot of work, isn't it? Well, what about if I did this? Let me get a different color. Purple. What if I made my rectangles this way? Oh, I got here. Let me use this. Now, there they are right there. This way is not top minus bottom. It's what? Where are your big numbers? Where are your big numbers? To the right. Where are your small numbers? So what you do is Josh lays down. He tips over. I tip over. His feet are over here. So are my feet. His head is further to the right than my head. Why? Because he's taller. It'd be right minus left, correct? Now, Nikita, I got another question. Where's Gavin sitting?
To my right.
I hate to say it. His number's bigger than yours. Whatever that number may be, you can decide. Okay? Gavin, how thick are these rectangles? Delta y. That means everything has to be in terms of y. Well, let's look at this. I'm going to take this right here. And I got y equals a negative x plus 2. So I'm going to get it in terms of y. I'm going to get x in terms of y. So I'm going to have x equals 2 minus y. And I'm going to give this a name. Oh, I don't know. I'll call it u of y. And it's to the right, isn't it? Now, over here, it connects to here, correct? So over here, I'm going to say y equals the square root of x plus 1. So I'm going to get y minus 1 squared is equal to x. I'm going to call that a name. I'm going to call it, oh, I don't know, r of y. Now, notice that when I take the square root, it would normally have a plus and minus. If I solve this for y, I'd take the square root, I'd have plus or minus the square root of x, correct? But since I squared, even if I took and squared this, if I would have said y equals a negative square root of x plus 1, I'd get y minus 1 equals a negative square root of x. And if I would square both sides, I'd get this, right? In other words, this graph all the way around is this in terms of y, isn't it? Well, why is that nice? That means my integral is going to be u of y minus r of y dy. Why is the u of y first? Because it is to the right. Why is the r of y last? Because it is to the left. Everybody with me on that? Now, am I going to use 0? Am I going to use 0.382? Am I going to use 2.618 as my A's and my B's? What am I going to use? I have to have my Y's. I had a Y way down here, correct? I had a Y way up here, correct? I still go those intersection points, but I use the Y's instead. I don't have to worry about this doodad right here, do I? I'm integrating from here on up. Is that making sense? It's a different perspective. That's what makes it tough. So did you figure out those intersection points? You got one. Which one did you get? And so this will be B, correct? What will it be? What was that intersection point when you put in 0.382?
1.636.
Okay. And what was the bottom? It'll be negative. It'll be a negative negative 6 point, negative. So I'm going to integrate from those. Do I know what area I'm going to get? What area should I get? The same. The shape didn't change, correct? I should get exactly, very good, Nick. I should get exactly, this is my area. But it's a lot easier because I only got to write one integral, correct? You have a confused look on your face. And what's your confused look? You got a Casio. You. Oh, some.
1.618.
What's this? This is wrong? Okay, it's 1.618, folks. Somebody said something wrong. And down here, this is an 8, not a 9. My 9s and 8s look the same. What did you do? Didn't you keep the original equations in? Did you keep the original equations in? Ellie, did you keep the original equations in? Square root of x plus 1. You still have to use those. You don't want to put them in terms of y, even though you can, because you can't find the intersection points when they're not in terms of y. Next page. Okay, can I go on? Now, let me talk about your calculator. Your calculator is stupid. It does not know the difference between x and y. So if I would go to my calculator, because I can see people wondering right now. All right, I'm going. Oh, I'll get this so you can see it. Turn this dumb thing off. Lamp. So I'm going to integrate. I'm going to go math 9. And I'm going to put in the numbers. You said a negative 0.618. Am I right?
Yes.
And up here I had 1.618, correct?
Yes.
It just knows those are numbers. Who knows those are y numbers? You do. Correct? And the first function I put in was to the right. It was u of y is equal to what? What did I say?
2 minus 4.
So I'm going to put in parentheses 2 minus x. I know that's x and it's not y, but your calculator doesn't know that. It just knows it's a variable. Minus parentheses, what's my other one?
X minus 1 quantity squared.
Yeah, so parentheses x minus 1 parentheses squared. And that's it, right? X. And I get the same answer. So don't say, hey, I got to put everything in terms of y. Even though on a Casio you can, you don't have to. You can draw them in terms of y. You cannot figure out the intersection points in terms of y. So you got to go back to your original graph, figure out what your y values were. And so when I graph something, I write down the ordered pairs for the points. I go, oh, good, I've got those in case I need them in x, in case I need them in y. Okay? So I'm going to do this. This one was y squared plus 2x. I know it's a parabola. I know it's going up. I believe it looks like this. This point right here, I believe, is a negative 2, 0. I don't like this pen. It's too thick. Over here, this is the point 0, 0. How do I know that? I said 0 equals x times x plus 2, and I drew that graph. Y equals a negative x looks like this. They must intersect at this point. Ooh. X is 0. And x equals a negative 1. Excuse me, x equals 1. So x equals 1 is right here. So I'm looking at this graph right here. Here's x equals 0. It's the area that's bounded by this, this, and this. So notice, I got x equals 0. That's this, the y-axis. X equals 1 is this. X squared plus 2x is this. And x equals a negative x is this. So I initially thought it was this till I looked at these last two lines, and I realized this is the area that I'm computing. So I'm going to integrate from what to what? John said 0 to 1. Does everybody agree? Because it starts here and stops at x equals 1. This is a boundary right here. What over what? Is it are my rectangles going left and right, or are they going up and down? Up and down. How thick are they? Dx. So it's top minus bottom. What's top?
X squared plus
x squared plus 2x minus, what is bottom? Negative x. Does everybody see how I set that up? This would be one I expect you should be able to do by hand. So I go from 0 to 1, I get x squared plus 3x dx. Would you agree? Antiderivative. Maureen, what's the antiderivative?
1/3 x to the third power x cubed plus 3/2 to the second power.
And are you happy to see 0?
Yeah.
Are you happy to see 1?
Yeah.
So my answer is 1/3 plus 3/2. You're probably not happy with that. Are you okay with fractions? Common denominator is 6. So I get 2/6 plus 9/6. I think I get 11/6. Is that right?
Yeah.
Do you see why with 0 in here, this is a decent one to do? Find the area bounded by this. So 1, 2, when I put 0 into here, it goes down. G of x equals x is this. So I'm bounded by this and this. So here are my rectangles. So I can figure out where they intersect. So usually I do this by hand if I don't get a calculator. So I get 0 equals x squared plus x minus 2. Is that factorable? I believe so. 0 equals x, x. Two numbers that give me, when I multiply, give me a negative 2, and when I add them, give me 1. What do they got to be? Plus 2 minus 1. So x equals a negative 2, x equals 1. That makes sense by my drawing, doesn't it? So I'm going to integrate from negative 2 to 1. Am I going too fast? Alrighty, so what am I going to write here? Maya, what's the top equation? Minus, right, the bottom equation, which is what? X dx. So what's the antiderivative of 2, Maya? I don't, that's the derivative of 2.
2x.
What's the antiderivative of x squared?
1/3 x cubed.
What's the antiderivative of x?
1/2 x.
Evaluate from negative 2 to 1. If I put, now I can't, I gotta actually do work. So I'm going to put 1 in there, I'm going to get 2 minus 1/3 minus 1/2 minus, I made myself enough room, a negative 4 plus 8/3 minus 2. I don't know how you do this. I write it like this, 2 minus 1/3 minus 1/2. This is a negative 6, so I got plus 6. And then this is a minus 8/3. So I get 8, because 2 plus 6 is 8. A negative 1/3 minus 8/3 is a negative 9/3, so it's minus 3. boom, 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 minus a half. 8 minus 3 is 5, minus a half is 4.5. That must be my answer. We are going to stop now.